Hello and welcome to episode 4 of the Chemistry Made Simple podcast. I'm your host Matthew Macario. This week we're going to be talking about atomic orbitals. And of course we're going to make this topic as simple as possible. Not always easy with chemistry. So what do we need to know? Well, we're going to define what do we mean by an atomic orbital. What types of atomic orbital are there and what shapes are they? And which orbitals do we find in which electron shells? So let's start with what is an atomic orbital. An atomic orbital is a region within a shell where there's a high probability of finding electrons. And this region has a shape, and the shape depends on which orbital type we are considering. So what types of orbital are there? Well, there are many, but we only need to consider the four most common ones. And those are given names or labels S, P, D and F. And each of those types has a shape as well. We need to know the approximate shape. So let's start with the S orbital. The S orbital is a spherically shaped region, and there is an S orbital in each shell of an atom. So the first shell has an S orbital. The second shell has an S orbital, the third shell has an S orbital, and so on. And we actually put the shell number before the name in order to indicate which it is. So in the first shell, the S orbital is called the 1s. In the second shell, the S orbital is called the 2s, and so on. Next we come to the p orbital type. And the p orbital type doesn't exist in the first shell. It exists in the second shell onwards. So we have 2 p orbitals, 3 p orbitals, 4 p orbitals, and so on. And in the shells that have p orbitals, there's always 3 of the p orbitals. Those orbitals are described as dumbbell in shape. The 3 of them are the same shape, just along the different axes. So there's one along the x-axis, one positioned along the y-axis, and one positioned along the z-axis too. And the same in the third shell and the fourth shell, and so on. When we have a set of orbitals of the same type in the same shell, we call that a subshell. So in the second shell, we mentioned there are 3 p orbitals, and those collectively we call the p subshell, or the 2p subshell, because it's in the second shell. In the third shell, we call the collection of p orbitals the 3p subshell. In the fourth shell, we have a 4p subshell, and so on. And you'll see and hear the phrase subshell used quite regularly, and be expected to recognise it and understand it when it comes to exams. Now, the third type of orbital that we need to consider is the d orbitals. And these exist from the third shell onwards, so we don't see them in the first or the second shell, but we see them in the third shell, fourth shell, fifth shell, and so on. And in each shell that d orbitals exist, there are 5 d orbitals. So our d subshell in a particular shell has 5 orbitals in it. So in the third shell, our 3d subshell has 5 orbitals. In the fourth shell, the 4d subshell has 5 orbitals, and so on. And the shape of these is too complex to describe in just words, so you can see what they look like by getting hold of the download available at the end of this episode. Finally, we come to the F type of orbital, and the F orbital is even more complex in shape, but you don't need to know or recognise the shape of the F orbital at this level. And F orbitals exist from only the fourth shell onwards, so there's a 4f subshell, a 5f subshell, and so on. And that subshell is a collection of 7 orbitals. So the 4f subshell has 7 orbitals, 5f subshell has 7 orbitals, and so on. Something important to talk about when we consider subshells is that they have individual orbitals within them that can accommodate up to 2 electrons each. So let's consider a p subshell. In the second shell, for example, our p subshell has 3 p orbitals, and each of those orbitals can accommodate up to 2 electrons. So that means the p subshell can accommodate up to 6 electrons. Now in the second shell, we also have an s orbital, and that can accommodate 2 electrons too. So in total, the second shell with its s and its p orbitals is able to accommodate 8 electrons, 2 from the s orbitals, 6 from the p orbitals. And that's why the second shell is able to accommodate 8 electrons. And hence in period 2 you see 8 elements, because each element has 1 more electron than the previous element. Now let's take that to the third shell. Third shell has an s orbital which can accommodate 2 electrons. It has a p subshell of 3 orbitals that can accommodate between them 6 electrons. And it has a d subshell which has 5 orbitals, so there's another 10 electrons possible there. So the third shell altogether can accommodate 18 electrons, 10 from the d orbitals, 6 from the p orbitals, 2 from the s orbital. And that's why as you go further down the periodic table, you'll see that there are periods across the periodic table that have more than 8 elements, because there are shells that contain more than 8 electrons. And as we mentioned in the last episode, this expansion of shells as we go from one shell to another, the increase in size and accommodation of electrons, means that our periodic table ends up the shape it is. It's not just 8 elements wide. Okay, let's try and summarise this, but from a shell point of view. So we said that an orbital is a region in a shell that can contain up to 2 electrons per orbital. We also said there are subshells within shells to a group of equivalent orbitals. We also said that in the first shell we can have s orbital, in the second shell we can have s orbitals and p orbitals, in the third shell we can have s orbitals, p orbitals and d orbitals. In the fourth shell we can have s, p, d and f orbitals. So each successive shell has got the same types of orbitals as the previous shell plus 1 extra type. And that does actually continue after the fourth shell, but we don't need to go there for this level. So how much of this do you need to know? Well, if you're studying the advanced higher, you need to be aware of s, p, d and f orbitals, and you need to be aware of the shape, be able to recognise the shape of s, p and d orbitals. If you're studying A level, the requirement is slightly lower. You need to be aware of s, p and d orbitals, and you need to be aware of the shape of s and p orbitals. And of course you need to be aware of how many orbitals and in which shell, regardless of which of those syllabus you're studying. Those requirements apply if you're studying for the 2021 or 2022 exam season, but if you're studying for a later season, if you're listening in the future, please be aware that sometimes syllabus requirements do change. And in that case you need to either check your syllabus requirements or speak to your teacher to find out what changes to the requirements there may have been. Here's how to get that download I mentioned, which has a summary of what we've spoken about today and also shows you the shape of the orbitals that we've talked about today. So if you go to chemistrymadesimple.net/orbital, you can download that. That's all for this episode, so come back for the next episode and we'll be talking about mass spectrometry. Don't forget, if there's a topic or a particular question in chemistry that you want to hear an episode about, then just get in touch. Best ways of contacting me: DM me on Instagram, it's chemistrymadesimple, or email me, matthew@chemistrymadesimple.net, and I spell Matthew with 2 T's. Until the next episode, goodbye.